In an increasingly connected world, access to fast and reliable internet isn't a luxury, it's a necessity. But what happens when you're flying at 35,000 feet or living in a remote area without traditional infrastructure? That's where satellite networks come in. In this project, we set out to explore how satellites, especially low Earth orbit constellations, can help bring high speed internet to even the most hard to reach places. While satellite networks hold huge potential, they also come with major challenges. Satellites have limited power, and connections are constantly changing as satellites move around the Earth. That means every transmission has to be fast, efficient, and reliable. Our goal? Build a simulation tool that helps us better understand how these satellite networks behave and how we can improve them.
The objective of this project is to design satellite networks that aim to answer key questions like, how do we build a satellite network from scratch? How can we measure and compare the reliability of each connection? What's the best satellite for a moving aircraft to connect to? And what's the most efficient route to send data across the globe? On top of that, we also trained a machine learning model that helps us predict the load on each satellite, essentially how busy it is at a given time. By estimating how many active connections each satellite is handling, our tool helps balance the traffic across the entire network, making sure no single satellite gets overwhelmed. All of these components work together to give us a clearer, smarter picture of how satellite networks can be optimized.
Our simulator is made up of 5 key modules: network topology, which builds the virtual satellite network; link budget, which checks how strong and reliable each satellite link is; access, which helps us find the best connection for things like aircraft in motion; routing, which picks the most efficient path across the entire network; and a user interface, which brings it all together in one place. The result is a visual, easy-to-use tool that shows how satellite networks perform under different scenarios, whether you're analyzing aircraft connectivity or simulating global data routes. Our tool helps visualize the invisible and brings complex systems to life. With adjustable settings and clear outputs, users can explore how different network configurations impact speed, reliability, and overall performance.
Here's our look at our simulator in action. Watch how different modules work together, from selecting a satellite constellation to finding the most efficient route across the globe. What we have built is just the beginning. As satellite technology continues to grow, tools like this will be essential in designing networks that are faster, smarter, and more accessible. In the future, we hope to add even more features, like testing different internet protocols, simulating real-time congestion, and improving how our machine learning modules interacts with the network. We'd like to give a huge thanks to our mentors, Professor Halim Yanikumereglu, our amazing TAs Diraj, Ethan, and Pablo for their continued guidance throughout this journey. And thank you for watching.